Yes, hello everybody. Thank you for having me. I'm Jan-Willem Könemann. I work at TNO, the large research organization in the Netherlands. And within TNO, I work for the unit energy transition. Yes, okay. Thank you, Oscar. So within TNO, I work for the unit energy transition, and hopefully, yes, this works. And within energy transition, I work in a cluster called synthetic fuels and chemicals. And synthetic fuels and chemicals is about combining captured CO2, well, TNO is an expert in CO2 capture, and green hydrogen, also there we have a lot of knowledge, but combining them and produce the fuels and the chemicals that industry and the transport sector need in a sustainable future. So what are we producing? We would like to have a simple, robust, efficient, single-step conversion to the commodities like syngas, formic acid, formaldehyde, methanol, DME, or ethylene, and finally kerosene. So the formaldehyde and the kerosene are not one single step, but these are our focus points. And well, this little conference workshop is about e-fuels, so I focus not on the chemicals for industry, but now more on the e-fuels. And especially I would like to focus on two e-fuels, that is kerosene and DME. In both we have multiple projects at this moment. Well, first, synthetic kerosene. Well, first of all, the conventional route to synthetic kerosene, because it already exists. Shell has really large plants in Qatar and in Malaysia that are already producing synthetic kerosene. The only difference is that the input of those plants are a fossil fuel, mostly natural gas or some other gas which is there at the moment, and they are producing synthetic fuel to make it easy to transport. Now what we are doing at TNO is we would like to change that first step. If we can produce syngas, then this already proven large-scale Fischer-Tropsch technology can be used to produce synthetic fuels like synthetic diesel, synthetic kerosene, like they are already doing today. It will be on a smaller scale than exists today, but still it is the technology which is already out there, and therefore it is really promising. But we are also, yes, looking at another line. Here we have a big European project called Takeoff, and we are looking at the route to kerosene via methanol. So we produce from CO2 and hydrogen in one reactor methanol or DME. In another reactor we go to light olefins. By the way, this is a really important chemical feedstock. This is the largest chemical commodity in the world, ethylene, propylene. And from that we go to kerosene. And doing it like that, we think that we can, well, that is our target, we have to prove that in this project, we can only produce kerosene, the fuel blend, and no side products. So there will be no LPG-like light fuels and also no heavies left. All the costly hydrogen will be into the kerosene, and therefore we think that the kerosene can be a lot cheaper than the synthetic kerosene is today, because it is a lot more expensive than fossil kerosene and also a lot more expensive than bio kerosene at this moment. And then there's also an even more aggressive step in this same project, is that we say, well, let's skip the whole methanol DME and immediately make in one step light olefins and then in the second step kerosene. That is the objective of our Takeoff project. But I would like to also look again a little bit at the second step, because this morning we already said that probably in the Netherlands there can never be enough, well, renewable energy, wind power, to well, electrify anything and to produce all these fuels to replace the fuels that we are producing today in the Netherlands. It's not really possible, but still, I'm quite a big fan of chemical industry. I would like to keep that industry, the work and the earnings in the Netherlands. So this intermediate methanol and DME, and then I especially think about methanol because it is a liquid, is an interesting intermediate, because you can produce methanol or ammonia in a country where the renewable energy is cheap, and then transport that to the Netherlands, and over here upgrade it to kerosene and other products. And I do think that the main commodities, the most interesting commodities there are the liquids, because it's easy to transport. And I will tell you a little bit more about DME later. Now, what are we doing at TNO? We are developing technologies. And the development targets, there's not enough time in 10 minutes to explain you the technologies in great depth. But what would we like to achieve in technology producing syngas? Well, we would like to have a one reactor step, efficient and robust, that connects directly to the Fischer-Tropsch reactor with the right temperature and the right pressure. So that will be as simple and straightforward as possible. Methanol or DME. DME is dehydrated methanol, so both occur in the same reactors, in the same reaction path. We would like to produce that methanol or DME or blends perhaps in one reactor step with high conversion. And with methanol or DME, the conversion is restricted because hydrogenation reactions are a balance. So typically, if you have a one-step reactor, you produce 10% DME, and then you have to recycle 90%. So you have huge recycles and you have huge purification streams. And we are at this moment upgrading that to 85% in one step, which means that the recycle, if there's any recycle, will be really small. And then also the plant could be downsized a lot. And we would like to have a high selectivity to the product. So in the future, we would like to have a reactor, which is maybe more complex, but with a high conversion and not a lot of downstream purification and processing and separation. Just make the product that you want to make. Same goes for the kerosene fuel blend. That is a little bit more complex, so we need a little bit more steps. But also there, I told you takeoff is about high selectivity to desired kerosene. So produce kerosene and no lights, no heavies. And also there, kerosene fuel is a blend. That blend can also be optimized to burn even cleaner in a jet. After all, it is process intensification that we do, and we would like to achieve lower cost in the future and a reduced economy of scale, because the really large scale refineries will be reduced to smaller scale facilities in the end. Now, then a touch about our technologies. These two technologies are both separation enhanced processes. Now, I'm not going into the chemistry here, but you see the reaction for DME on the top right. 3 of the 4 reactions produce water. These are equilibrium reactions. If we remove the water, the reaction is pushed to the right side, to the desired product, meaning that we can actually go from this 10% to 85% conversion in one reactor step. Now, how to remove water in a reactor? Now, the SETMAS technology, sorption enhanced DME synthesis, is already at TRL 5. You see here this nice setup that we have in Petten. does that by adsorption. So there's an adsorption material between the catalyst in the reactor taking up the water. And then we have the Sienna technology, which is somewhat lower in TRL. You see this is a lab unit at this moment. This is working with a membrane and an internal cooling rod. So here, actually, the water passes the membrane, is condensed, and leaves the reactor as a liquid, making sure that all the hydrogen stays in the reactor, because hydrogen is by far the most costly thing in any kind of synthetic fuel or chemical. Now then, I thought, well, let's talk a little bit about kerosene and DME as the examples. Now, already a lot has been said about kerosene. Why is it important? Because airplanes fly on kerosene and will fly on kerosene for the coming decades if you have a long-haul flight. Well, first things is hydrotreating vegetable oils. HEFA, Sky Energy is doing that. But there's a limit in the amount of waste oils in the world. So those will be the first plants. Then you have biomass, alcohol to jet or gasification. But in the end, also there the space for agriculture is limited. I know that in America, they have a lot of biocrops producing a lot of fuels. But here in Europe, especially in the Netherlands, that will be more difficult. And that's why you see at the bottom, there are targets for renewable fuels of non-biological origin, which is a really difficult name for a synthetic fuel. And that in the end, that it has to produce its share. So there will be, well, perhaps 50-50 bio origin and synthetic origin kerosene made. And then DME, the friendly chemical. DME is a really nice molecule. It's 2 methanols without 1 water produces DME. It's not really known, dimethyl ether. And now, the current use in Europe is actually the propellant gas in hairspray or deodorant. So there you see it's a really friendly chemical because you're not spraying anything in your face which is not, which is hazardous or poisonous. Or this is really a nice chemical. So it's a small commodity at this moment. However, it is much more efficient to produce DME than to produce, because it still contains an oxygen. That's that red ball that you see. It still contains an oxygen, and it requires a hydrogen molecule to take out any oxygen molecule. So, because it contains oxygen and it is a good fuel, it takes much less hydrogen to produce, and therefore it is cheaper and more efficient. Now, DME is already explained this morning, can be an excellent diesel replacement. Trucks are already driving all day. Of course, you need a different fuel tank because DME is a gas. You need a fuel injection system, but then your truck can drive on DME. I think the main hurdle here, it's also soot-free, by the way. DME does not produce any soot. The main hurdle here is, of course, the infrastructure. You tank your diesel at a gas station, and there is currently no DME infrastructure there. So this will be a big thing. And what will be that infrastructure? Will this be electricity for every car or truck at the end, or will heavy trucks still need some kind of liquid fuels? We don't know yet, but making this infrastructure is, of course, a very big thing. And therefore, there's even a more interesting market for DME, and that is LPG. DME is an excellent replacement of propane-butane. Now, what is propane-butane in the Netherlands? If you go to camping, we have this little tank we cook on. Well, that is propane-butane. But in other countries in Europe, when you're a little bit off-grid, a little bit in agriculture, then you have a gas tank, like you see here from Prima Gas. There's a really large company in the Netherlands that does all this distribution. And that company, with its Chinese competitor, formed a really big new company to produce DME, to replace LPG in the end. Because DME production costs a lot less hydrogen than LPG production, and it can be replaced, it can be blended in, and it can use the same infrastructure. So here, the problem we have with diesel is not there. We can just blend it in as a drop-in fuel. And then, last but not least, like I showed, DME and methanol are an intermediate to other fuels and chemicals like synthetic aviation fuel, but you can also think of the chemical industry and the plastic products that we have. Thank you.